Here are the answers to the Day 1 study guide. This is going to cover chapters 1 and 2. Copy each sentence, making it true by replacing the question mark with a number or with an equals or not equal to symbol. The question mark is located where we need a number. So right here, we need to have the number 9, so that 4 plus 9 is equal to 9 plus 4. Number 11, the question mark is also located where we need a number. If the right side is 10 and we want the left side to be equal to 10, what do we need right here? Well, what do we need for the numerator so that when you divide by 2, you get 10? The numerator has to turn out to be 20. Knowing that, we can figure out that the question mark has to be a 6. Number 16. This time, we don't need a number, but we need the equals or the is not equal to. Is the set containing 1, 3, and 5 equal to the set containing the odd integers? Or is it not equal? This time it is not equal. While these are odd integers, this first set is not all of the odd integers, which is what the second set description describes. Number 19. The question mark is located for a number. If we want the left side to end up being an element of the set containing 6, then the left side has to turn out to equal 6. What does the numerator need to be so that when you divide by 3, you get 6? The numerator has to be 18. Knowing that, we can see that the question mark has to be a 3. Next question. Let set U equal the set containing -7, 27, and 14. List all of the subsets of U that have exactly one element. We're listing sets, so we need to have the brace notation, and we want to have one element in the brace. So we could have only the element -7. This smaller set is called a subset of the original, or we could have the set containing the number 27, or we could have a set containing the element 14. All of these have one element in there. Let's do this again, but put two elements in the braces. So we could have -7 and 27, or maybe our subset has the -7 and the 14. Or we could make a subset containing the numbers 27 and 14. This is all of the ways to choose 2 out of those 3 numbers. Number 23. How many subsets can we pick that have 3 elements? There's only one possibility: to choose all 3 of the elements to put in the set. Next, list the members of the following sets. List all of the values of R such that R is an integer and it's not 0. So we want all of the integers that are not a 0. There's going to be a lot of them. We could have -3, -2, -1. Don't put 0, but then we could have 1, 2, 3, and so on. I'm using the ... to show that the negative numbers continue forever and that the positive choices continue forever. I've listed every integer, but not 0. Number 9. List all of the sets R such that R is a subset of the set containing these 2 numbers. Well, one possible set is to choose both of the elements. But another possible subset is to choose only one of the element. For instance, the set containing only the 0. Another possibility is the set containing only the 1. And the final possibility is to choose neither of the elements. That creates a subset. It's called the empty set. Number 11. Find all of the numbers x such that x is an element of the set containing 5 and 6. Well, one of the numbers that x could be is 5, and the other number that x could be is 6. Here are our choices for x. Next, graph the following subsets of the real numbers. This implies doing this on a number line. The first number to graph is -1. Just put a little closed-in dot for that. Then graph 0, and then graph +1. Number 7, graph all of the numbers p such that p is an integer and it's less than 6. So again, this implies drawing a number line. We want all of the integers that are less than 6. So we don't want to include 6, just the ones less than 6, like 5, 4, 3, 2, and so on, going to the left forever, including the negatives. So we want to have dots on these numbers. Number 4, graph all numbers y such that y is less than or equal to 3. This time, nothing tells us we're restricted to integers. We're going to show all real numbers less than or equal to 3. Here's where 3 is. Because this says y can equal 3, you use a closed dot, not an open dot. Then you shade over all numbers less than 3. That would mean shading to the left. Shade the arrowhead to show that it continues forever. We've covered over 2 and 1. We've covered over negative numbers, but we've even covered over all of the decimal numbers. Number 10, graph all numbers y such that y is in between this number and this number. So make a number line, locate where -1 is and where +6 is. Pay attention to the inequality arrows. Because of those equal to symbols, they're closed endpoints. Then shade in between those endpoints. Because the letter y is in between those two numbers. Next, which of the following sets are closed? Closed means if you use only elements in the set and perform an operation, the answer you get must be within the original set. There's two questions. First, we're going to do question A, then we're going to do question B. Let's check addition. Remember, you're using only elements in the set. Your only choice is 0. So make an addition problem using 0. 0 plus 0 is our only possibility. 0 plus 0 equals 0. Is that answer in the set? Yes, it is. So it's closed under addition. Now let's make a multiplication problem. Again, our only number we can choose is 0. So 0 times 0 is our only possible question. The answer is 0. Is that in the set? Yes, it is. Number 5, we're going to do A and B. Natural numbers start with 1 and then count upwards forever. If you choose 2 natural numbers from the set and make an addition problem, are you going to get an answer that is a natural number? Well, let's try some. What if you chose 1 and 2? 1 plus 2 makes 3. That's in the set. What if you chose the number 2 and another 2? 2 plus 2 is 4. That's in the set. So the answer is yes, this is closed under addition. Now let's choose 2 numbers, multiply them together, and see if the answer we get is in the set of numbers. 1 times 1, the answer is 1, which is in the set. What if we chose 2 and 4? 2 times 4 is 8, which is also a natural number. So this answer is yes. Okay, now the squares of the integers. One integer is 0, and 0 squared is 0. Another integer is 1. 1 squared is 1. By the way, the integer -1, when squared, makes 1. Another integer is 2, and 2 squared makes 4. By the way, -2 squared is 4. Another square of an integer is 9. Another one is 16. Another one is 25, and so on. We're going to do question A and question B. Let's choose two numbers from our set and add them together to see if we get an answer in the set. Well, what if we chose 1 and 4? 1 plus 4 makes 5, and that is not in the set. So our answer is no, because of our counterexample, 1 plus 4 equaling 5. What about multiplying? 0 times 0 makes 0, which is in there. 0 times 4 makes 0, which is in the list. 1 times 1 makes 1, which is in there. 1 times 9 makes 9, that's in there. 4 times 25, that's 100. 100 is also the square of an integer. It's 10 squared. I think this answer is yes. I cannot find a counterexample. Next, give the solution set of the equations over the set of real numbers. Giving a solution set just means solve the equation. This is an absolute value equation. We want to know what p is equal to. P could be equal to -6, or p could be equal to +6. Because if p was -6 and you substitute in those bars, the absolute value of -6 does turn out to be 6. Number 4, solve this one. Well, all we got to do is get rid of the negative. So divide both sides by -1. We get y equals 2. Next, graph each solution set over the set of real numbers. This implies graphing on a number line. The absolute value of y is less than 0. Well, first let's algebraically solve this, and then we can graph our result. When we have an absolute value expression with a less than symbol, what kind of numbers could you put in for y so that this ends up true? There are no answers that work for y. If you try 0 for y, the absolute value of 0 is not less than 0. If you try a positive number for y, such as 2, the absolute value of 2 does not turn out to be less than 0. And if you try negative numbers for y, it's not going to work either. Like, what's the absolute value of -3? Well, that makes +3, which is not less than 0. So because it's empty set, there's nothing to graph on the line. Number 19, let's solve for r by dividing by the -1, which is its coefficient. When you divide by a negative, do you remember what happens to the arrow? It switches direction. And 1 divided by -1 is -1. Now we'll graph this on a number line. Here's -1. We need an open dot and then shade to the right. Next, we're going to do what's called a proof. A proof has 2 columns. The first column heading is called statements. The second column heading is called reasons. For the first statement, you use the hypothesis of your sentence. The hypothesis is the portion that goes with the word if. What you do is you just copy that down. AC is equal to BC, and C is not 0. That's given to us in the beginning part of our sentence. So your reason is given. Then keep in mind what you're trying to create. The conclusion is A equals B. We want to start with this equation and do something algebraic and end up with A equals B. Can you think of a way to make those C's cancel away? Let's divide by C. If you divide both sides by C, you get A equals B. Now, what's the reason you're allowed to divide both sides by C? That's called the division property of equality. So this proof had only 2 steps. The first step was simply to write down the given information, and the second step was our conclusion. Most proofs are much longer than that. Next, find the following sums or differences. So number 2, this is simply adding 2 negative numbers together. Because there are no variables, you could type it in the calculator, or you can add them by hand. A negative number plus a negative number is a negative answer. Then add the 48 plus 36. That makes an 84. So the answer is negative 84. Number 3, there are no variables. You could type this in the calculator, or you can do it by hand. This is negative 71 plus positive 30. Now that we have an adding problem, use the adding rule. The larger of the two numbers is negative, so the answer is negative. Then 71 take away 30 is 41. The answer is negative 41. Number 5, we're back to an adding problem where both of them are negative. So the answer is negative. And 19 plus 17 is 36. The answer is negative 36. Number 8, we're back to a subtraction. So negative 14 plus positive 81. Now that we have an adding problem, use the adding rule. The larger of the two numbers is the 81, and it's a positive number, so the answer is positive. Then figure out what 81 minus 14 is. That makes a 67. So the answer is 67. Number 13, again, there's no variables. You could type this straight in your calculator, even put the parentheses, push enter when you get to the end, and you'll have it. Or you can do the problem by hand. 7 plus 11 is 18. Negative 8 plus negative 10 is negative 18. These cancel, so the answer is 0. Number 25 is find the difference. The word difference means subtract them. How is the temperature changing when you start at 8 and you end up at negative 2? The temperature has decreased 10 degrees. The difference is negative 10. Mathematically, if your ending temperature is negative 2 and you minus your starting temperature, you get negative 10. Next, find the indicated products or quotients. Again, you could type it in the calculator or do it by hand. We have 4 numbers times together and one of them is 0. So the answer is 0. Number 3, negative times negative makes positive. Before we times the 14 and 12 and get a pretty large number, we could save some work by reducing the 7 in the denominator with the 14, leaving a 2. Now we have 2 times 12 times 1. That's 24. So the answer is 24. Number 6, we have multiply and we have adding. So you need the order of operations. Multiply comes before any adding. 31 times 2 is 62, and 31 times 8 makes 248. That was done with the help of a calculator. Now add those together. This makes 300. This makes 310. There was another way you could have done the problem if you noticed it. You see how the 31 is in both products? We could have used the distributive property. Factor out the 31, leaving 2 plus 8. 2 plus 8 makes 10, so 31 times 10 is 310. Number 7, do the work in the parentheses first. So we have 10 minus 5, and then in parentheses it turns out to be 20. Now do the multiply before the subtract. So we have 10 take away 100. That makes negative 90. Again, this has no variables. You could type this in the calculator and push enter. Number 12, looks like we have some dividing. So 64 divided by negative 16 makes negative 4. We want to divide that by negative 2. Negative divided by negative makes positive, and 4 divided by 2 makes 2. So our answer is 2. Number 19, we have some brackets and some parentheses. You work from the innermost grouping symbols out. So the first thing to do is the 3 plus 1, making a 4. Then go 4 times 4 making 16. So in the brackets, we have 36 take away 16. That makes 20. Over here, we have another set of grouping symbols. 4 minus 6, well, that makes negative 2. So our 20 gets divided by negative 2. That answer is negative 10. Next, identify using the word monomial, binomial, or trinomial. After you do that, figure out the degree. Number 2 has no plus or minus signs that separate into terms. This has only one term, so it is a monomial. Now what its degree is the sum of all the exponents. 1, 1, and 1. This is degree 3. Okay, question 3 has a subtraction sign, creating 2 terms. So that's a binomial. For the degree, you use the highest degree in both of the terms. So what's the degree of the first term? What's its exponent? It's degree 2. But what's the degree of this term? What's the sum of its exponents? 2 plus 1, that's degree 3. Between those two degrees, the higher degree is degree 3. Okay, last one has some plus and minus signs which separate it into terms. And there are 3 of them, so it's called a trinomial. Now let's get the degree. What's the degree of the first term? Sum the exponents, degree 7. What's the degree of the middle term? It's degree 3. What's the degree on the last term? Sum the exponents, 1 plus 2, that's degree 3. So from these 3 choices, which is the highest degree? It's degree 7. Next one, find an equivalent polynomial in simple form. That means simplify. We could do the work in the parentheses, or we could do the distributive property. I'm going to do the distributive property. 50 times 1/5 is 10, and 50 times 1/2 is 25. That makes 35. Number 7, let's do some combining like terms. 9x plus 5x minus 3x. 9x plus 5x is 14x. 14x minus 3x is 11x. Now the constants. Positive 2 minus positive 8. That makes a negative 6. Number 9, we need to do some distributive property. So r plus 7 times r is 7r. 7 times s is positive 7s. Right here is going to be distributive property. Negative 8r and negative 8s. And then on the end is plus s. Now combine like terms. 1r plus 7r is 8r, and then minus 8r. The r's cancel. Now let's look at s. 7s plus s makes 8s, but then minus 8s cancels. The final answer is 0. Number 15 is also combining like terms. The highest degree is the x cubed. Here and here, let's combine those. We get 8x cubed. The next highest degree is our x squared. Here and here. We have 7x squared plus 4x squared. That makes positive 11x squared. Notice I'm not changing the variable name when I do combining like terms. I'm not getting 11x to the 4th. The name of the terms is x squared. Now let's combine our x terms. Here and here. We have negative 3x plus 5x. That's positive 2x. And finally our constants. Positive 1 and a minus 18. That's negative 17. Number 21, we have to do some distributive property because there's a number right in front of parentheses. So we have our 5t plus 3s, and now let's distribute the minus 2. Negative 2 times 2t is minus 4t. Negative 2 times negative 4s is positive 8s. Right here is some distributing as well. This makes positive 15s and positive 24t. Now combine the s's. We have 3s and 8s and 15s. That's 26s. Now the t's. We have 5t, take away 4t, which makes 1t, and then add 24t, which makes positive 25t. Next, evaluate the variable in the left member. That means solve for the letter on the left side of the equation by using the given values for the other variables. We're solving for d, and we're going to substitute numbers. For the letter A, we're supposed to fill in 32. For the letter T, we're supposed to fill in a 3. We can work this out by hand, but because of the large number 32 and because of the squaring, it might be best to type this in a calculator. The answer is 144. Next, solve the equation and check your answers. On the exam, you're going to have to show work steps. So the first thing you do is you subtract 3 because that isolates the 2x term, making a 6 over here. Then you divide by the coefficient of 2 because when the 2 cancels, the letter x is alone. 6 divided by 2 makes 3. Because it says check your answer, go over here and substitute the number in place of x in the original problem. Does that make 9? 2 times 3 is 6, and 6 plus 3 makes 9. This checks. Number 3, combine like terms. 5m plus 4m is 9m. Now subtract 72. So we have 9m equals negative 72. Now divide by 9. So we have m equals negative 8. Let's check our answer. 5 times negative 8 plus 4 times negative 8 plus 72. We want to know, is that equal to 0? This is negative 40. This is negative 32. And then plus 72. That does make 0. It checks. Number 5, we have an x term on both sides. So let's subtract the 4x so there's not an x term on the right side. 6x subtract 4x makes 2x. Now let's subtract the 4. We have 2x equals negative 2. Then divide by the coefficient of 2. We get x equals negative 1. For the check, fill in negative 1. On the left side, we have negative 6 plus 4. That's negative 2. On the right side, we have negative 4 minus 2. That's negative 6. These do not check out. So that tells us we have a mistake. Let's try this problem again. The first thing I did is I subtracted 4x. 6x minus 4x is 2x. And then I brought down the plus 4. Oh, I see my mistake. That should have been negative 2. So let's correct that mistake and continue from there. When you subtract 4, you get 2x equals negative 6. When you divide by 2, you get x equals negative 3. Let's check it again. Six times negative 3 is negative 18. Negative 18 plus 4 makes negative 14 on the left side. 4 times negative 3 is negative 12. And negative 12 minus 2 makes negative 14 on the right side. This checks. Number 7, we have variable terms on both sides. Let's fix that by subtracting the 3x. 5x subtract 3x is 2x. Now let's subtract the 8. We get 8 equals 2x. Now divide by the 2. we get 4 is equal to x, which with the symmetric property is the same thing as x equals 4. Now let's do our check. Three times 4 is 12. 12 plus 16 is 28. Over on this side, 5 times 4 is 20. And 20 plus 8 is 28. This checks. Number 14, we have like terms. They both have the letter n. And they even have common denominators. So we can subtract these fractions. 2/3 n minus 4/3 n is negative 2/3 n. And that's equal to 3. Now, multiply both sides by 3 to get rid of the denominator. We have negative 2n is equal to 9. Then divide by negative 2. We get n equals 9 over negative 2. You could write negative 4.5 if you like, or negative 4.5. These are all the same thing. Let's check our answer. Two times negative 4.5 is negative 9, and negative 9 divided by 3 is negative 3. Negative 4 times negative 4.5 makes 18, and 18 divided by 3 makes positive 6. Negative 3 plus 6 is equal to 3. This checks. Number 15, let's do the distributive property. 2 times 2x is 4x. 2 times minus 1 makes negative 2. Next, combine like terms. On the left side of the equals, negative 2 and positive 4 just makes positive 2. Next step, subtract 2 from both sides. 4x equals 24. Then divide by the coefficient of 4, getting x equals 6. Now let's check the answer. In the parentheses, 2 times 6 is 12. 12 minus 1 makes 11. So we have 2 times 11 plus 4. This is 22 plus 4, which is 26. This checks. Next, solve the inequalities and graph the solution sets. Solving an inequality is very similar to solving an equation. Get the letter x alone. So first, subtract 5 from both sides. We have 2x is less than or equal to negative 2. Notice I'm keeping the same symbol here. I'm not accidentally changing to equals as I go. Next, divide by 2. We get less than or equal to negative 1. Now we're going to graph that solution set on a number line. Here's negative 1. It gets a closed dot because of this equal symbol, and you shade to the left. Number 3, add 5 to both sides because adding 5 will cancel the negative 5. Now we have 40. Notice when I canceled the negative 5, I was careful to keep that minus 1. Now divide by negative 4. When you divide by a negative, what happens to that arrow? It switches. And 40 divided by negative 4 makes negative 10. Now we can graph that. We need an open dot because the arrow has no or equals. And again, it points to the left, so you shade to the left. Number 5. Let's subtract 2a from both sides. We have 8 is less than or equal to 1a minus 4. Now add 4 to both sides. We get 12 is less than or equal to a. Now apply the symmetric property to switch sides. If 12 is less than or equal to a, then a is greater than or equal to 12. Now we can graph it. Number 9, I notice that there's some parentheses and a number right in front, so that makes me think of doing the distributive property. 5 times c is 5c. 5 times 3 is positive 15. Now let's combine like terms. So we have 5c plus 19. Now I notice the letter C on the left side and the right side. Let's subtract it from the right side. So we have 4c plus 19 is less than negative 1. Now subtract 19 from both sides. We have 4c is less than negative 20. And then divide by 4. We have c is less than negative 5. My arrow stayed the same every single step. Number 1, we want to graph the solution set on a number line. This one has an absolute value. So let's do algebra first and then graph our result. When we have an absolute value expression with an is less than, the way that we rewrite it using algebra is to take the opposite of the 2, to say less than, then to take the expression in the bars, which is x, say less than again, and then take the 2. We can graph this. We have negative 2 and positive 2, open dots on both endpoints, and shade in between, because the letter x is written in between those two endpoints. Here's another graphing problem. It also has absolute values. We're going to graph it on the number line, but not until after we've solved it with algebra. When an absolute value problem has an equal symbol, the way that you rewrite it with algebra is the expression in the bars is equal to negative 9, or the expression in the bars is equal to 9. Now solve both of these statements. So we need to add 1, so we get 2x equals negative 8, and then we need to divide by 2, so we get x equals negative 4. The other one is solved the same way. When you add 1, you get 2x equals 10, and when you divide by 2, you get x equals 5. We can graph those two numbers. Negative 4 gets a dot, and positive 5 gets a dot. Number 7 is another absolute value, but this time with an is greater than symbol. So we are going to graph it on a number line, but not till after we've done algebra. We're going to rewrite this. To rewrite an absolute value with an is greater than, you take the expression in the bars and you put less than negative 3. Then write or. Now take the expression in the bars and say greater than 3. Solve both of these. Looks like we need to add 4 to get the y alone. This makes 1. When you add 4 over here, it makes 7. And we can graph these statements. Here's 1, here's 7. They get open dots. Where is less than 1? It's left from the 1. Where is greater than 7? It's to the right from the 7. So in those 3 questions, we practiced an absolute value that had a less than, we did one that had an equals, and we did one that had a greater than. All of them had their own way of rewriting using algebra. Next one, specify by roster. That means list numbers. The following subsets of the integers. We want to find all numbers t such that it solves this. This is simply another way of solve the inequality. So first thing to do, subtract 5 from both sides. We get negative 8 is less than or equal to 2t is less than or equal to 6. Now what do you do to get t alone? How do you get rid of the 2? Divide by 2. So negative 4 is less than or equal to t is less than or equal to 3. We're told to put we're told to specify by roster to actually list numbers, and the numbers we're listing are integers. So what are the integers that fit within this range? -4 works, -3, -2, -1, 0, 1, 2, and 3. I'm going to stop at 3. Here is our list of answers. Number 1, determine the solution set. That means solve it. We have an equation, and the equation has a 0 on the right side, and the left side is in factored form. That's really good because it makes it easy for us to solve. Take the first factor and say equals 0. Take the second factor and say equals 0. And then solve each of them. So you add 10 to both sides, getting 5t equals 10, and then divide by 2. T equals 2. On this one, we need to subtract 24. So 4t equals -24. Then divide by 4. So t equals -6. These two numbers are the answers. Number 5, do you notice the format that you have? It's got equals 0, and on the left side, it is factored form. So take the first factor, which is just a t by itself, and say equals 0. Take the next factor, which is 2t plus 1, and say equals 0. And take the next factor, which is 6t minus 48, and say equals 0. This first one is already solved, but these next two we can do some work on. If you subtract 1, you get -1. Divide by 2, you get -1/2. On this one, you have to add 48. Then divide by 6. Here are our 3 answers for t. Next, we have an algebraic expression, 5y. We're asked to give 2 interpretations for it and specify an appropriate replacement set for the variable. So an interpretation of this expression could be as straightforward as a literal translation into words. This is 5 times y. This is an interpretation of what those symbols mean. What's an appropriate replacement set? Well, what kind of numbers could you times by 5? Y could be any real number. Now let's do another interpretation. It could be the product of 5 and y. And again, what kind of products could you make? Like what kind of numbers would make sense for y to make products with 5? Y could be any real number. Number 3, what's an interpretation? Well, how about 2 more than x? What's an appropriate replacement set for x? What kind of numbers could you add 2 to? Probably any real number. So x could be any real number. Let's make another interpretation. How about this is the sum of x and 2? And again, you could make sums with any real number. There's no reason to limit ourselves to positive numbers only or integers or anything like that. Number 2, find 4 consecutive even integers whose sum is 236. Instead of just guessing numbers, I'm going to use algebra to do this. I'm going to choose the letter x to be our first integer. The next even integer would be x plus 2. The next even integer after that one would be x plus 4. The next even integer after that would be x plus 6. So these algebra expressions can model my 4 unknown integers. We're told that the sum is 236. The word sum means you add them together. X plus 2 plus x plus 4 plus x plus 6 is 236. Now let's solve the equation. First, combine like terms. We have 4x plus 12. Then subtract 12 from both sides. So we have 4x equals 224. Now divide both sides by 4. The result for x is 56. So our first unknown integer was 56. What's the next even after that? Well, our expression shows it's 2 more than x, so it's 58. Then 60, then 62. If you add those 4 numbers together, it makes 236.